For an 800 amp underground service, the National Electrical Code (NEC) provides guidelines for selecting the appropriate wire size and conduit. Two options are available, both comply with the NEC. First option involves using 600 MCM wire. For this option, 2 parallel runs of 4-inch rigid conduit are required. The second option involves using 500 MCM wire. In this case, 2 parallel runs of 3.5-inch rigid conduit are required. The electrical drawing for the project specifies 2 parallel runs of 3.5-inch conduit and 500 MCM wire. This option meets the NEC requirements for an 800 amp underground service. Therefore, the electrical drawing is correct. Several NEC articles and tables are relevant to this determination. Firstly, Article 310.15b3 addresses underground services less than 25 feet long. Secondly, Table 310.16 provides ampacity ratings for 600 MCM and 500 MCM copper conductors in conduit. Thirdly, Table 310.31H2 details conduit fill requirements for parallel conductors. When selecting conductors for electrical installations, several factors must be considered. These include ampacity, voltage drop, insulation type, and environmental conditions. Ampacity refers to the maximum current a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables that list the allowable ampacities for various conductor sizes and insulation types under different conditions. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. Insulation type refers to the material used to insulate the conductor. Different insulation types have different temperature ratings and are suitable for different applications. Common insulation types include THHN, THWN, and XHHW. Environmental conditions can also affect the choice of conductors. For example, conductors installed in wet locations must be suitable for wet locations. Conductors installed in direct sunlight must be sunlight resistant. Conduit is a protective enclosure for electrical conductors. It protects the conductors from physical damage, moisture, and other environmental factors. The NEC specifies the types of conduit that are permitted for different applications. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. When selecting conduit, several factors must be considered. These include the size of the conductors, the number of conductors, the type of environment, and the mechanical strength required. The size of the conduit must be large enough to accommodate the conductors without overcrowding. The NEC specifies the maximum number of conductors that are permitted in a conduit of a given size. The type of environment can also affect the choice of conduit. For example, conduit installed in wet locations must be suitable for wet locations. The mechanical strength required depends on the application. For example, conduit installed in a location where it is subject to physical damage must be stronger than conduit installed in a location where it is not subject to physical damage. Parallel conductors are 2 or more conductors that are connected in parallel to increase the ampacity of a circuit. The NEC permits the use of parallel conductors under certain conditions. When using parallel conductors, all of the conductors must be the same size, length, and insulation type. They must also be installed in the same raceway. The ampacity of the parallel conductors is equal to the sum of the ampacities of the individual conductors adjusted for any applicable dirting factors. When installing an 800 amp underground service, it is important to follow all applicable codes and standards. This will help to ensure a safe and reliable installation. Before beginning any electrical work, it is important to consult with a qualified electrician. A qualified electrician can help you select the appropriate conductors and conduit for your application. They can also help you ensure that the installation is done safely and in accordance with all applicable codes and standards. The NEC provides detailed requirements for sizing conductors and conduit for electrical services. These requirements are based on the ampacity of the service, the type of conductors used, and the type of conduit used. The NEC also provides requirements for the installation of electrical services. These requirements are designed to ensure that the service is installed safely and reliably. When installing an 800 amp underground service, it is important to pay close attention to the NEC requirements. This will help to ensure that the installation is done correctly and that it will provide reliable power for years to come. In addition to the NEC, there may be local codes and standards that apply to electrical installations. It is important to check with your local building department to determine what codes and standards apply in your area. By following all applicable codes and standards, you can help to ensure a safe and reliable electrical installation. Remember that electrical work can be dangerous. If you are not qualified to perform electrical work, it is important to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and correctly. Attempting to perform electrical work yourself can be dangerous and can lead to serious injury or death. The choice between using 600 mcm wire with 4-inch conduit or 500 mcm wire with 3.5-inch conduit depends on several factors, including cost, availability, and ease of installation. Both options are acceptable under the NEC, so the final decision is a matter of engineering judgment and practical considerations. It's crucial to consult the electrical drawings and specifications for the project and ensure that the installation complies with all applicable codes and standards. If there are any discrepancies or questions, it's best to consult with a qualified electrical engineer or inspector. Understanding ampacity correction and adjustment factors is also vital. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its insulation temperature rating. This rating is typically based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductor must be derated. Derating factors are provided in the NEC tables. For example, if the ambient temperature is 40 degrees Celsius, the ampacity of a THHN conductor must be derated by 0.88. This means that the conductor can only carry 88% of its rated ampacity. Adjustment factors are also used to derate the ampacity of conductors when there are multiple conductors in a raceway or cable. The NEC specifies adjustment factors for different numbers of conductors. For example, if there are 4 to 6 conductors in a raceway, the ampacity of each conductor must be derated by 0.80. This means that each conductor can only carry 80% of its rated ampacity. The NEC also provides requirements for grounding and bonding electrical systems. Grounding is the process of connecting the electrical system to the earth. This provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Bonding is the process of connecting all of the metal parts of the electrical system together. This helps to ensure that all of the metal parts are at the same voltage potential, which reduces the risk of electrical shock. The NEC specifies the types of grounding and bonding conductors that are required for different electrical systems. The NEC also specifies the methods that must be used to ground and bond electrical systems. When installing an 800 amp underground service, it is important to follow all of the NEC requirements for grounding and bonding. This will help to ensure a safe and reliable electrical system. Understanding conduit fill is another crucial aspect of electrical installations. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. The NEC limits the amount of conduit fill that is permitted to prevent overheating of the conductors. The NEC specifies different conduit fill limits for different types of conduit and different numbers of conductors. For example, the maximum conduit fill for a rigid metal conduit with 3 or more conductors is 40%. This means that the total cross-sectional area of the conductors cannot exceed 40% of the cross-sectional area of the conduit. To calculate conduit fill, you need to know the cross-sectional area of the conductors and the cross-sectional area of the conduit. The cross-sectional area of a conductor can be found in the NEC tables. The cross-sectional area of a conduit can be found in the conduit manufacturer's specifications. Once you know the cross-sectional areas of the conductors and the conduit, you can calculate the conduit fill using the following formula. Conduit fill equals total cross-sectional area of conductors / cross-sectional area of conduit times 100. If the calculated conduit fill exceeds the NEC limits, you will need to use a larger conduit or reduce the number of conductors in the conduit. Proper conduit fill is essential for ensuring the safe and reliable operation of electrical systems. Overfilled conduits can lead to overheating of the conductors, which can cause insulation damage, short circuits, and fires. Therefore, it is important to always follow the NEC requirements for conduit fill. In summary, determining the correct wire size and conduit for an 800 amp underground service involves considering the NEC requirements, ampacity, voltage drop, insulation type, environmental conditions, conduit type, conduit fill, grounding, and bonding. Consulting with a qualified electrician or engineer is recommended to ensure safe and compliant installation. The electrical drawing indicating 500 cm conductors and 3.5-inch conduit appears to be the correct and compliant option, provided all other installation requirements are met. Always prioritize safety and adherence to the NEC and local codes. Regular inspections and maintenance are also essential for ensuring the long-term reliability of the electrical system. Be sure to properly torque all connections to prevent loose connections and potential overheating. Label all circuits and components clearly for easy identification and troubleshooting. Keep accurate records of the electrical installation, including drawings, specifications, and test results. And ensure that all personnel working on the electrical system are properly trained and qualified. By following these best practices, you can help to ensure a safe, reliable, and efficient electrical system. The choice of conductor material, typically copper or aluminum, also impacts the required conductor size. Copper conductors generally have a higher ampacity per unit area compared to aluminum conductors. Therefore, for the same ampacity requirement, an aluminum conductor will typically need to be larger than a copper conductor. The NEC provides separate ampacity tables for copper and aluminum conductors. When selecting a conductor material, it's important to consider the cost, weight, and availability of each material. Copper is generally more expensive than aluminum, but it is also more conductive and less prone to corrosion. Aluminum is lighter than copper, which can be an advantage in some applications. The termination of conductors is also a critical aspect of electrical installations. Proper termination techniques are essential for ensuring a reliable and safe connection. The NEC specifies the types of connectors that are permitted for different types of conductors and different applications. When terminating conductors, it is important to use the correct tools and techniques. Over-tightening or under-tightening connectors can lead to loose connections and overheating. It is also important to properly insulate all connections to prevent short circuits. Regular inspection of terminations is essential to identify and correct any loose or corroded connections. Infrared thermography can be used to detect hot spots in electrical connections, which can indicate a problem. By properly terminating conductors and regularly inspecting terminations, you can help to ensure a safe and reliable electrical system. Considering the underground nature of the service, the type of insulation becomes particularly important. Insulation needs to be rated for direct burial or suitable for use in wet environments. Common insulation types for underground applications include underground service entrance cable, and XHHW, cross-linked polyethylene, high heat resistant, water resistant. Specific requirements for underground installations are detailed in the NEC, including burial depth, protection from physical damage, and proper backfilling procedures. The depth of burial depends on the voltage and the location. Typically, services require a minimum burial depth to protect the conductors from damage due to digging or other activities. Proper backfilling with suitable materials is essential to prevent damage to the conduit and conductors. Sharp rocks or debris should be removed before backfilling, and the soil should be compacted to provide support. The physical protection of the conductors and conduit is also crucial, especially in areas where there is a risk of mechanical damage. Concrete encasement or other forms of protection may be required in some cases. Additionally, proper drainage should be provided to prevent water from accumulating around the conduit. Water can damage the insulation of the conductors and cause corrosion of the conduit. By following these guidelines, you can help to ensure the long-term reliability and safety of the underground service. Coordination with the utility company is also an important step in the installation process. The utility company will typically have specific requirements for the service entrance equipment and the connection to their system. It is important to contact the utility company early in the design process to discuss these requirements and ensure that the installation complies with their standards. The utility company may also require an inspection of the installation before they will connect the service. This inspection is to ensure that the installation is safe and meets their requirements. Communication with the utility company is essential for a smooth and successful installation. Before energizing the new service, it is important to perform a thorough inspection and testing of the installation. This includes testing the insulation resistance of the conductors, verifying the grounding and bonding system, and checking the voltage and current levels. The results of these tests should be documented and kept on file for future reference. After the service is energized, it is important to monitor its performance regularly. This includes checking for any signs of overheating, unusual noises, or other problems. Regular maintenance, such as tightening connections and cleaning equipment, can help to prevent problems and extend the life of the service. And remember, electrical systems can be dangerous, so it is important to always follow safety precautions and consult with a qualified electrician if you have any questions or concerns. The proper selection and installation of surge protection devices, SPDs, is also a critical consideration for electrical services. SPDs are designed to protect electrical equipment from voltage surges caused by lightning strikes, switching operations, and other events. Voltage surges can damage or destroy sensitive electronic equipment, so it is important to install SPD to protect your investment. The NEC requires surge protection for certain types of electrical services, and it is generally recommended for all services. There are different types of SPD available, each with different characteristics and performance levels. The selection of the appropriate SPD depends on the specific application and the level of protection required. SPD should be installed as close as possible to the equipment they are protecting, and they should be properly grounded. Regular testing of SPD is also important to ensure that they are functioning properly. The single line diagram for the electrical system should be reviewed and updated to reflect the new service. The single line diagram is a simplified representation of the electrical system that shows the major components and their connections. It is used for planning, design, and troubleshooting purposes. The single line diagram should be accurate and up to date to ensure that it is a useful tool. Finally, it is essential to maintain detailed documentation of the electrical installation, including drawings, specifications, test results, and maintenance records. This documentation is valuable for future troubleshooting, maintenance, and upgrades. It is also required by many codes and standards. The documentation should be stored in a safe and accessible location. By following these best practices, you can help to ensure that the 800 amp underground service is installed safely, reliably, and efficiently. And it's important to remember that electrical work can be dangerous, so it's always best to consult with a qualified electrician if you have any questions or concerns.